Hello and welcome to today's MTD podcast. I'm joined by three very special people. The first one is David Hanley, Managing Director and owner of Thame Workholding. David has been with Thame since 1985 and he's a true engineer at heart with a career that includes subcontract manufacturing, design, and of course is a workholding expert. We have Matthias Meyer, the CEO of HWR. He heads up sales and technology for the company that was founded in 1989. And finally, Giovanni Albanese is our in-house resident workholding expert with 25 years experience in workholding and aerospace subcontract manufacturing. So welcome, gentlemen.
Hello.
Welcome to everybody.
So David, if I can come to you first, Thame Workholding, just give us a brief history, if you will, and how you're involved with HWR.
Oh, certainly. Thame was incorporated in 1946. I wasn't there then, by the way. And that's 74 years it's been going. It's had various incarnations, but in its current form, it's been going just over 30 years. And I've had an association, or the company's had an association with HWR since 1990. We first met Volker Henke, the at the time managing director, and from there he sold our jaws all throughout Germany. And I've known HWR for 30 years, and I've known Matthias for 11 of those years.
So there we have it. So how do you find the HWR product?
They're very innovative. They're superb quality, and they fill a nice gap in our market. So you'll see, and when we talk a bit more, when Matthias explains them, they're excellent.
Okay. On that note, Matthias, if I can come to you, obviously you're CEO of HWR. Where do you feel your product fits in the marketplace, and what makes you different to maybe some of the competitors?
Well, I think our product range fits in nearly every area of milling and turning industry. There's non-specification whether it fits perfectly for medical customers. It fits perfectly for aerospace. It fits for cast iron parts. It fits for forging parts. I think there's non-specification for our clamping technologies in the area.
Okay, and Gio, have you come across HWR? Obviously, you used to sell workholding. Have you come across Thame and HWR on your travels?
Oh, blimey, yeah, I came across Thame a lot over the years. They were one of our fiercest rivals at the time, and they had some fantastic products, and we were all on the same path, really, all on the same road. Trying to help engineers become more profitable, trying to help engineers become more efficient, and like we always mention, Joe, workholding, in my opinion, is still a very big overlooked element and part of the process. And without the correct workholding solution, you can't use that machine tool to its full capability. You can't present as many components to the spindle as maybe you can. You're not utilising the machine tool envelope. If you haven't got the right workholding, it can create vibration. You've got to slow down your feeds and speed. So, I've came across Thame, and they've got an extensive portfolio of workholding products. With HWR product portfolio, I've not really came across them as such in the past, but I'm definitely interested to find out more.
Okay, so Matthias, so I just come back to you. HWR, you've had an unprecedented year in terms of bringing technology to the market. You've got an incredible amount to talk about. So maybe we'll start with your new solid line and everything that fits within that solid line, and then we'll come to you, David, for your point of view after.
So we had 16 years experience with clamping technology in the field of milling clamping technology. And in 2018, HWR decided to become a manufacturer of milling clamping devices. And in special, we developed our SOLIDgrip center vices, our SOLIDpoint 0-point technology, and our SOLIDbolt 0-point technology. And in addition to the SOLIDgrip vices, our SOLIDstamp stamping technology.
So that's a lot of product to bring to market all in one go, but I guess it all complements each other. So in terms of, if we start at the base, if you like, the actual 0-point system itself, so not the vice, the 0-point system, how does that compare with other products in the market currently?
Yes, our SOLIDpoint system, our 0-point system, is a manually activated system. It's one of the lowest systems in the market. It's only 27 millimeters. And we use the 96 millimeter and the 52 millimeter, I think you call it pattern grid, yeah, of the 0-point bolts. So, and due to that, it's compatible to existing 0-point system in the market.
Very good. And Gio, you've obviously got a lot of history with 0-point systems as well. What's the advantage of using 0-point systems?
It's an absolutely massive advantage, and I think there's still so many people out there that don't use 0-point, and I think it's an absolute cardinal sin, in my opinion. The main advantage is you've kind of got a universal datum point with 0-point location, so effectively it's eradicating all setup times. So you can do a lot of your setup off the machine. There's so many different variants of 0-point out there. You could have a 0-point system just to accommodate for one vice or for several vices, depending on the size of your milling machine. But in my opinion, it's definitely part of the future, whether that be a mechanical one or an automated one. And I think that for any engineer that doesn't use 0-point in this day and age is really at a massive disadvantage.
So, David, if I come to you, obviously you've got well over 35 years experience in work holding. How do you feel these products, how do you feel they fit, the marketplace when you've got, when you compare them to some of the other products that you've seen?
It's a fantastic range of products, and just if anybody wants to see them, come here, because we actually use them as well. If anybody wants to see 0-point, that's just another thing. Listen to Gio. If anybody wants, we're at HP189EJ. We're right in the middle of England. So, yeah, if anybody wants to come and see 0-point being used every day, all day, come and have a look. But, yeah, with SOLIDpoint, it's fantastic that we've now got 52 and 96 in the same plate. It saves us chopping and changing, putting adapters in. We can go from a fixture to a tiny little vice in one go. The lads love it. It's great.
Yeah, so, it seems it's one of those things you look at it and you think, why has it never been done before? Because I'm sure there's a lot of technology into the design and the manufacturing, but the principle is very straightforward, isn't it? You have to question why it was never done before.
Yeah, it's a very simple design. That's the thing. I mean, the old existing ones were clever for their day, but they've had their day. This is a much simpler design, much higher pull-down pressures, much better for harder materials where there's less vibration. And so I can see it's a great market. As Matthias said earlier, the 0-point is the real new technology.
Sure, and they're not as tall either, are they? So presumably the big advantage is obviously you're given your z-axis, more, you've got more z-axis stroke if the 0-point's thinner.
Yeah, it's you're not eating up any of the envelope. No. The other lovely thing about it, and you maybe can see on the videos, is the clever idea of actually scribing a line on the top face of the 0-point where you drill. So you can drill anywhere on that plate where it's marked outside of the mechanism. So that's really nice. So people won't drill through their mechanism like in the good old days where you couldn't see what was going on in the plates.
Yeah, it's a good idea. And for people unfamiliar with generic stamping technology, Matthias, What is the advantage of stamping a billet prior to the machining process?
I think the biggest advantage is that you only need a clamping depth of 3 millimeters. The second big advantage is that you only need a few seconds of preparation your raw material, and you can after these few seconds of preparation right with the milling on your machine. I think these are the biggest two advantages of the stamping technology.
Sure. And David, these are often referred to as 5-axis vices, aren't they? This stylage, but it's not just for 5 axes, of course.
It's not. It's for 3 axis. We use it on. We've got a very small little vertical that we use it on. And the other thing that does make it very flexible, and the third thing I'd add to Matthias there, is the first two that he had mentioned, but the third is that vices don't need the power. So the vice is a much lighter construction, and you can move it around from one station to another. So you can actually move it from your lathe to your mill or to your CMM and back again. So you can carry the vices, where on a lot of standard type vices, you can't carry them around. And so with just one screw, you undo, move the vice to another station or another machine, and you're away.
And Gio, do you have anything to add?
Yeah, I think that obviously they're market leaders in regards to 5-axis technology for a long time within the UK, Thame Workholding. And in regards to the crimping, you're holding on excess material. So that 3 mil excess material, you're actually just holding, and all the stresses and forces are going through that excess material. So effectively, the component that you're making is in a free state. You're machining that in a free state. So the vibrations don't exist. And that's really the clever point about it. I mean, some of these components that you see that are sticking out so far from the clamping area look unbelievable. You'd think, how can you machine that without vibration? But the proof is in the pudding.
Yeah, no, that's a very good point. Some of these, you see it in the 4th axis where you would think, where all the forces are going down, you think it would fly out. But of course, with this clever stamping technology, you're absolutely right, Gio. The technology, there's very little harmonics, there's very little vibration. Of course, it's a very, very stable process. So, Matthias, we've also got, you've also got the solid chuck. What is the solid chuck?
The solid chuck is a 3-jaw chuck, especially for milling operation. It's compatible to our SOLIDpoint 0-point system, and it's a very light, very effective, very simple 3-jaw scroll chuck. Okay,
and why would an engineer use this ahead of the previous products we've talked about? Is it purely to hold a round billet?
It would generally hold a round billet much better than you would have to pre-op a SOLIDgrip to be able to hold a round billet in SOLIDgrip. But yeah, in the solid chuck, you can hold it. It's specific for certain products, not really heavy machining. So. But we have other things for heavy machining, and that will be Interflex, which we'll talk about as well. So
yeah, no, for sure. So, but the actual solid chuck is, itself, it's a manual chuck. It's a lightweight chuck. It's easy to use, and it can be taken from machine to machine.
It can, and it can be used in automation as well. So.
Yeah, so the actual chuck gets loaded the same as the vice?
Yep, it can be. So.
Okay. And in terms of a lot of the, excuse me, a lot of the repeatability of these types of equipment, it's down to the pull stud, what I class as the pull stud. What is the HWR pull stud like? How accurate is it? How repeatable is it? And talk to us about, the forces and things.
Well, from the pull stud will repeat it seems to get better over age, and they repeat to within about 5 microns if you take them off and put them back in the same place. But generally, if you said 15 microns, it's fine. But if you're using the same plate again, as I say, they just go back in almost absolute position. The 16 mil and 20 mil, they're compatible with our old system. It's exactly the same. But the pull down pressure, as I said earlier, is 3+ times. And so the vibration is much less.
Okay, because it's worth pointing out a number of engineers won't use a vice. They will use these straight into the billet of the material. And they will just use the 0-point system to hold them.
Yep, that's right.
Yeah, certainly larger components.
Yeah, on larger components, it's easy to pre-op, put 4 holes in, and put your billet straight up. We do that ourselves, and we make some of our very large jaws that way. We just take a round bar, stick 4 studs in it, and then we're away. Maybe put it up on one of our 5-axis machines and forget it for the rest of the day.
Sure. And Matthias, is this something you see a lot in Germany, this approach?
Yes. A lot of customers do that as well in Germany. They just put the 4 studs in their custom devices or in the workpiece itself or in other devices from other manufacturers.
And Gio, is this an approach you'd recommend?
Yeah, absolutely. I think that it just shows the versatility of the system. So you're not looking at it as one particular product. So you've got interchangeability and flexibility between a chuck, between a vice, or like mentioned, if you wanted to put a large billet directly onto the 0-point system, you can. And again, that will also save you Z envelope. It'll also, as mentioned before, if you needed that extra 100 mil Z stroke, that may be able to be a solution to achieve that. Going back to the chuck as well, really, it goes to show that every application is different. So, say for example, you were doing a thin-walled round part. You don't need the same amount of clamping force to hold that. In fact, you need to have kind of full wraparound to hold that to stop distortion. So every application component is different, and you need to have a solution for all.
Yeah, for sure. In terms of the solid line, obviously that's all new, and I see that being exceptionally successful in the UK and no doubt globally. Thame Workholding, you've sold a number of products for a number of years very successfully. And another one of those products that you've sold successfully is the Inno line. At MTD, we've seen a lot of the InnoFlex and the InnoZ. But for maybe people listening to this who aren't necessarily aware of that product, Matthias, can you just give us a brief overview of the product line and the thinking behind the product line?
Yes. The Inno line, the Inno product line, is our product range for mostly turning clamping systems. And our main product in the Inno line is the InnoFlex system. The InnoFlex system is a compensating 4-jaw chuck that gives the opportunity to clamp nearly any shape of workpiece in one and the same chuck with one single set of jaws. So it doesn't depend whether your workpiece is square, rectangle, round, or an irregular shape. You can clamp nearly any shape of workpiece in this compensating 4-jaw chuck.
David, obviously, I know what a compensating chuck is, but can you just explain how that fundamentally works? If you've got an irregular shape, how do you present that to the chuck?
Well, the chuck has jaws, as any other type of jaw, whether it's a soft jaw or a hard jaw. And the chucks have serrations on the master jaws. But what happens is 2 jaws come in and touch on the component, and then the other 2 opposing jaws come in and touch again on the component. And when they all touch together, it clamps up concentrically. And there's a little mechanism inside that allows this to happen. So two opposing jaws come in, pinch against the part, the other two opposing jaws come in, and then they all pinch together. So it's concentric on all occasions, whether, as Matthias says, whether it's square, whether it's rectangle, whether it's a diameter.
Sure. It's very clever, isn't it? And
it's very clever. Come and have a look at one.
Yeah, for sure. And on the larger side, I think you call them the VL from memory, but they're modular, aren't they? You start off with something that can be relatively small, but it's the modular. You keep bolting them onto this lightweight chuck, and you can go up. I don't know, maybe 2 meters in diameter.
Yes, exactly. We have the small size chucks. We start from 160 millimeter. And we go up with the light version, the Enoflex VL light version, up to 2 meters.
Wow, it's incredible, isn't it? Yeah, it's incredible. And Gio, are these projects you've come across before? These self-centering vices, chucks rather.
Well, yeah, this is probably one of the most innovative products that work holding products that I've seen for some time. I don't believe there is anything else on the market such as this, and I think that it's very innovative for lots of reasons, really, because it's self-centering from both sides. So, like David mentioned, it's centralising the components. So, say for example, if you had components with any irregularities in castings, for example, where it alleviates any casting variation, it will always bring that component to the center. So a really great solution for some of them kind of more specialized applications, I would say.
Yeah, when I used to sell cutting tools, one of the hardest applications was when you were looking to machine either tube or some components with very, very thin walls. You would have to significantly reduce your cutting data. You would quite often get chattering. It would just be a very unstable process. But I know HWR have got a solution for this as well, David.
Oh, they have. Let's just go back to what Gio said. He said that he thought that that the VL or the Enoflex was special applications. It's not special applications. It could be used on anything. It could do away with the 3-jaw, 2-jaw, 4-jaw combination where people are changing from one to another. You just don't need it. It can all be done in the one chuck. So if subcontractors changing from one to another, where often they change from a 2-jaw to a 3-jaw, back to a 2-jaw, then a 4-jaw because of the castings, you can do it all with the Enoflex, one chuck. So not so much special. Well, it is special, but it's not for special applications. It's really good. So, yeah, the other is you'll have to refresh me, Joe. Forgot what you said.
Yeah, no, just saying when I used to sell tooling, you get called into machine either tube or a boring bar down a tube, basically thin wall turning. It used to be it used to be particularly unstable, but I know HWR have a solution for this.
Yeah, it's the InnoZ system, and this is the pivoting, adjustable jaw system that mounts onto the face of nearly every chuck, or any chuck we can mount it to, providing we know the details. I mean, we make lots and lots of special applications dedicated to the one diameter or 2 or 3 diameters, but with the Enoflex, it's just flexible. InnoZ, it's just flexible across the range. You can put bridges on, what we call bridges, mount to the base jaw, and then you have independent jaws, so you can get 6 or 12 points of grip, so around a diameter.
Yeah, so essentially, Matthias, you're turning a 3-jaw into a 6-jaw potentially.
Yeah, that is what we call it. We call it an upgrade system. We can upgrade any existing 3-jaw chuck into a compensating 6-jaw chuck with the InnoZ system, or we can upgrade any existing 4-jaw chuck into a compensating 8-jaw chuck.
Yeah, no, it's fascinating. And Gio, what are the advantages of adding more jaws to a chuck?
I think in my opinion, I think it's to stop distortion on thin walled parts. To have full wraparound location is a massive advantage. to cover more of the surface area around the diameter. Like with pie jaws, for example, which Thame Workholding also sell is another solution for that. Apologies about the Interflex system, David. I mean, what I was referring to really there was the kind of casting applications where you have got when you do need to centralize the components. You don't need the need for a special chuck. You can still use the Interflex as well. But yeah, I agree. I think the flexibility of the systems and the innovation does save changing from one system to the other, and I think that obviously again that saves a lot of setup time.
It certainly does. And the other thing, we HWR HWR do them for lathes, but there's also a 160 and a 210, I think it is, for milling, or is it? Matthias will tell us. And that,
yeah, the VF version. I think you're regarding the VF version.
The VF version, yes, and it's got the 0-point stud connections on, so it'll drop on and off straight away off on the milling machine. So, and it's a manual version. Whereas most of the other, they are manual, open center, closed center, and it uses the same cylinder and cylinder stroke that's on your standard machine that's taking Samchuli or Killigower. So it's very flexible.
Again, it's a fantastic product range. Certainly with the addition of the solid line, you've got vast, and arguably you've got something for pretty much every machine tool out there, Matthias. But just if I could be cheeky, I know you've launched a lot in 2020, but what's next? What's on the horizon? Any more products?
Yes, of course we have a lot of ideas, but in fact we don't have the time to get them in steel and iron. But to give a small overview over the next products, I think we're going to introduce our 4-way 0-point plate, SOLIDpoint, and one of the next products will be a new chuck in the Inoflex range.
Okay, so more products all around, really. And David, Thame, you're happy to continue to support HWR in the UK. It's a good product for you guys.
Certainly are. We've had a long association together, and long may that continue. But we enhance these products as well. Like we'll mount them onto fixtures. We make fixtures. We mount them into fixtures. As a lot of people know, Thame, we make thousands and thousands of standard jaws, but we make hundreds of specials and chucking systems, fixturing systems, vacuum systems, automation systems. We're designers and manufacturers here in England, so we integrate the HWR products, and they integrate very well.
Well, it sounds like a perfect marriage. So thanks for your time today, David, Matthias, Gio. Wonderful to have you on the podcast. And until the next time, this is the MTD podcast.
Thanks for listening to the MTD podcast. If you found value in this episode, please subscribe and leave a rating and review. Find more episodes on MTDCNC.com.